Hello, this is Mr. Collier, and today we're doing the trapezoidal rule. Alright, so sometimes it's not possible to work out an area exactly. We need to do an estimation, and one way to do that is with a series. Well, you can use rectangles, but a trapezoid gives you a bit of a better approximation. Okay, so here we can see a picture of function 12 over x is what it looks like. You can approximate the area under the curve using a bunch of trapeziums. Okay, so you can get the area of each one and add them all together to get you a total area. So here we have half. Okay, so we split them into equal trapeziums, and this looks like a width of 1 each time. Okay, so the height of the trapezoid is 1, and then the lengths of the bases. Recall the formula for the area of a trapezoid is half times a plus b times h, where this is the a and the b and the h, right? Parallel sides are a and b. Anyway, and here you can see this is 12 and this is 6, so you can do 12 plus 6 and times 1 because the height of the trapezium is 1. So that's just half of 12 times 6 is like 6 times 6, so it's 36. And the area of trapezoid 2 here, same formula. You can do half, and that's 8. So that's 6 and 4. 6 plus 4. Oh wait, I think I messed up the first one. That's a plus in between. So it's half of 12 plus 6, so it's 9. That's half of 10, which is 5. The next one is half of 4 plus 3. It's half of 7, which is 3.5. The next one is half of, that looks like 3 and possibly 2.5. Okay, so that's 5.5 divided by 2 is 2.75. You can verify that on your calculator. Next one's half of, that's 2 and 2.5. Okay, so half of that is half of 4.5, which is 2.25. Okay, then you can add them all together and get yourself a total area. This is 0.25, so this is like, well, let's add the whole numbers first. 4, 7, 12, 21, 21 plus, this is another 1 from the 0.25 plus that, plus 0.5. So I believe it's 22.5. Probably made a mistake in there somewhere, but you get the idea. We're doing the same thing over and over again, so that's perfect for a computer. Notice I added the 6 twice, and I added the 4 twice, and we added the 3s twice, and we have 2 of these 2.5s. But the 12 and the 2, they only happened once, okay? This is why, and we have this formula from the book. This is why we have these two separate parts. This represents the first trapezoid, and this is the last value that we had in this list, or 12, was the very first y value we got from the graph, and yn is the very last y value. So saying basically that this is like we take one of those each, and for each of the other numbers we multiply by 2 because there's 2 of them. Okay, and recall where we got these from. This is the first, well, we call this the 0th y value, I guess. y0, y1, y2. So all these y values here, we have to double them, except for the last one, we'll call it yn. Those are singles, okay? So that's where the formula comes from. So the y0 is the first y value, the yn is the last one, and the other y values are all the y values in between. H is the height of the trapezoids. So you can take your end point minus your first point and divide by the number of trapezoids you want to get your step size. And we'll see how this formula works in a bit. So that's 22.5. Let's get the exact area. You can use your calculator and do the integral from 1 to that 6 there, I believe. And the function is 12 over x dx. We'll just type that into the calculator. Here, we'll click here to get some stuff. Oh, let me just escape there. Okay, so 1 is the lower limit of integration, 6 is the upper limit. The function is 12 divided by x. And we always stick a dx there and click enter. We get 21.5. Okay, which, well, this is exactly 21.5. Ours was a slight overestimate, and you can see the trapezoids are a little bit above the curve, so it's an overestimate. Okay, but we were pretty close with the trapezoids, and let me demonstrate that if you increase the number of trapezoids, you get a better and better approximation. So it should be exactly 21.5. If you increase the number of trapezoids, you get closer and closer to 21.5. Okay, and basically what the integral does is it gives you like an infinite number of trapezoids, or an infinite number of rectangles, actually. All right, let's look at, this is the formula from the formula booklet. I kind of just discussed that. So yeah, you can see, the first value is the initial y value, and the last one is yn, and then all the other ones in between are y1 up to yn minus 1. Okay, so this formula just basically creates a bunch of trapezoids, which approximates the area. Okay, so let's take a look at another example, and let's use the formula directly. So we'll have half. Now h is, here's how you calculate it. H is b, so we're going from 4 to 12, so that's 12, and this is 4. Okay, so 12 minus 4 divided by n is the number of intervals. We want 4 intervals, so we divide by 4. So that is 8 divided by 4, which is 2. Okay, so our step size is 2, and you can see in the diagram we're going up by 2 each time. 4, 6, 8. Okay, so all these numbers are 2. That's basically the height of our rectangle. That's why it's in there. So we do half times 2, y0, y1. So let's write them in well, actually, sorry, they're already in the table, basically, right? That's y0 is 5, and then the last one is 4. Okay, now if you do this in the calculator, you do need all these brackets, or you might go wrong. And then all the other y values in between are 13, 10, and 3. Okay, so we can type that in. You might notice the half and the 2 cancel. We can type all that into our calculator, but it looks pretty easy to do otherwise. Let's try it. This is 9 plus 2 times, that's 26. So this is 2 times 9 plus 52. It's 2 times 61. So it's actually 122. Okay, that's 122. So it's a very easy formula to use. Okay, here we're going to estimate e to the x using 5 trapezoids. All right, 5 trapezoids. Now this is, the h is going to be 1 minus 0 over 5, and 1 divided by 5 is 0.2. So we're going to start from 0 to 1. So we're going to start with 0, this is going to be 1. We're going up in 0.2s. Okay, that's what the h is. We're adding h each time. 0.4, 0.6, 0.8. So we'll need these values. Let's get them from the calculator. So let's go to apps, function. I think I'm going to need to reboot my calculator. Hang on. Okay, let's go to function and type in e to the power of x, enter, and I'm going to go shift num because I want to start at 0 and I want to go up by 0.2, so I'm going to change the step size to 0.2, and well, I guess I could plot it. Yeah, well, actually you can see from here I need to plot it from 0 to 1 on the x and 0 to 3 on the y, so I'm going to go to shift plot, 0 to 1 and 0 to 3. Now I will get this curve right here. It looks like it starts right here and it goes up to 2, and well, actually that's going to be e to the power of 1, which is about 3.178, so it's going to be about there. Anyway, it's a curve that goes up like this, and we're basically getting a trapezoid. Let's draw the trapezoids like here. Oops, I didn't draw that very well. Okay, so we're just getting the area of all these trapezoids using the formula. Okay, it's not going to be perfect, but it looks pretty like it's pretty close. We can get the actual y values by going to num, and here they are. 0 is 1, 1.22, 1.49, okay, 1.82, 2.23, and that's 2.72. Okay, so we have all those values there. So using the area formula, the trapezoidal rule, we have half times h, which is 0.2, and the first y value plus the last y value, plus twice all the other y values. So 1.22 plus 1.49 plus 1.82 plus 2.23. Okay, so we can type all that into our calculator to get an estimate of the area. So half, I can type in 0.5, bracket 0.2, bracket, and another bracket on the inside. Oh, let's see, I think I messed something up already. Be careful about the placement of these brackets. There we go. So actually, I don't need the brackets there, really. 1 plus 2.72 plus 2 bracket, and type in all these numbers. 1.22 plus 1.49, 1.82, 2.23. Okay, it looks good. It matches the formula in the form of the booklet. Be careful the brackets are all placed correctly. Yes, so it should work, and we get 1.74. Okay, we get a 1.74. Okay, let's check it out with integration. It equals exactly the integral from 0 to 1 of e to the x dx. We can type that in here with the symbol here, and then 0 to 1. E is shift in this button. X is here. Here's x, so it is 1.7. It is exactly 1.718. Well, 2 to 3 seven figures, right? Okay. Okay, so that's actually still an approximation because we rounded. Find the percent error in the approximation above. So percent error is also in your formula booklet. Percent error, let's scroll back to topic 1. There's a percent error formula. Basically, we have the approximate value minus exact divided by exact. Okay, the approximate area is 1.74. The exact area, well, it's not technically exact, but it's very, very close. It's not exact because we rounded, but let's do it anyway. So yeah, we do that. Let's do that. So let's get this. Let's do 1.74. Actually, we do have the. We can use this this value here and just copy and paste. Oops. So let's make a fraction. And 1.74. I think I deleted it. All right. Well, anyway, 1.74 minus. Just use this number. This number again. Okay, you get this is scientific notation. If I change my settings to rounded, I won't get scientific notation. I'll get that. Don't forget to multiply by 100. And you get 1.26% error. Okay. 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 This next example, we want to approximate the area of this cross section of a river. And what we can do is we can get the area underneath the curve. And notice you got a nice straight line here. So you can take the rectangle and subtract the area using the trapezoidal rule, right? The area of that rectangle is 4 times 7 is 28. So we can do 28 and then subtract and use the trapezoidal rule. Half times h, you can see in the picture it's 1, times, and then we've got the first y value plus the last y value are both 4, plus 2 times all of the other y values added together. Okay, so that is an approximation of the area, and if you do all that on your calculator, make sure the brackets are correct, you get about 13.2, which makes sense because that's about half of 28, and it looks like about half, so it kind of makes sense. And next one, let's check this one out. So this is an island. So what you can do is you can get the area under, let's call it the north side. North side minus area under the south side will give you the area of the island. Okay? Area under south side. So that's just using the trapezoidal rule twice. So that's going to be half. And your step size here, let's see if it's, I guess it should be always a constant. You're going from 5 to 14, that's 9, 9, yeah, it's going up by 9 each time, so it's half times 9. Your first y value on the green curve here is 15, and your last one is 11, plus 2 times all the other y values, and you have to be careful. Now that's not, that's a mistake there, sorry. We have to look very carefully at the curve. F is the last one, right? This is the last one, so that should be 37 right there. And all the other y values, be careful, we need the y value of b. Okay. And then C, D, E. Okay, C, D, E. And yeah, that's the whole area on the top. And on the bottom curve, we again start with A, and we're also going up by the same amounts, 9. And so it's going to be 15 plus, this is going to be the same, this part. And I don't have much room to finish it, but we need to add on 2 times all those y values. So starting with the j, I guess, 26 plus 16 plus 12.5. And that's, is that it? 1, 2, did I miss one? I kind of went backwards here, I guess. G, H, I, and then J, yes, J as well. Okay, so if you type all that in your calculator, and actually I should have written a subtract sign here. Subtract those areas. If you type all that into your calculator, you get an approximation for the area of the island.